When it comes to the most destructive natural disasters, volcanoes are near the top of the list. When a volcano erupts, it can wipe out entire cities, poison people's drinking water, and starve millions by throwing so much ash into the air that not a single plant can grow for years. But believe it or not, all those drawbacks aside, scientists say volcanoes may be one of our best bets when it comes to fighting climate change. Volcanoes have been around since Earth was very young, but their presence is an inconvenient fact of life for only a small percentage of us humans. About 600 million people live within the danger zone of an active volcano, including 15 million people who live within the danger zone of one of the 500 or so volcanoes that scientists think might blow in the next 30 years. And it's these active volcanoes that researchers are keeping an especially close eye on, because while they are dangerous, they may also help fight the effects of climate change, if we can figure out how to use them. The reason volcanoes are such potentially useful tools to have in our back pocket has to do with what they're made of. Most of the world's volcanoes contain a combination of rock, hot magma, and dissolved gases like water vapor, but some contain much more gas than others. And while carbon dioxide makes up about half of all volcanic emissions, it's sulfur dioxide that has the biggest impact on our climate. Sulfur dioxide is one of several compounds that together make up acid rain, which can damage forests and poison aquatic ecosystems. That's not good. But in the right amounts, acid rain can also kill off the bottom layer of phytoplankton growing in our oceans. Phytoplankton are microscopic plants that float in the sunlit surface waters of our oceans, where they absorb carbon dioxide and release oxygen into the water and into the atmosphere. This process removes carbon dioxide from the atmosphere and releases oxygen into it, making phytoplankton a vital part of our planet's climate system and a critical tool for fighting climate change. In recent years, though, phytoplankton growth in some parts of our oceans has gotten out of control. Without predators to keep their populations down, these little plants have formed massive blooms that block sunlight from reaching deeper waters. That kills off other marine plants and animals, and disrupts the flow of carbon dioxide and oxygen between our oceans and our atmosphere. So in some areas, getting rid of some phytoplankton could be a good thing. And that's where acid rain comes in. Sulfate aerosols produced by volcanic eruptions containing lots of sulfur dioxide can linger in the atmosphere for months before they fall to the ground as acid rain. And in certain conditions, they can actually speed up the formation of clouds, which means that even more water gets dumped onto the ocean, where it can dissolve in the surface layer and sink down to the depths, taking carbon dioxide with it. Normally, that carbon would stay locked away in the deep ocean for hundreds or thousands of years, but in areas where there's been an upwelling of deep water, that carbon is brought right back up to the surface, where it can be released into the atmosphere again. And once it's in the atmosphere, it can start to trap heat and warm our planet. Some studies suggest that since 1990, this process has added as much as 20% of the excess heat trapped in our lower atmosphere. But when volcanic sulfate aerosols interact with phytoplankton, things get really interesting. While low levels of acid rain can keep phytoplankton populations under control, too much can actually end up helping them bloom. First, acid rain lowers the pH of the surface water, meaning it makes it more acidic. And a lot of phytoplankton species prefer more acidic conditions. Second, the nutrients contained in the sulfuric acid itself can act as fertilizer for phytoplankton. And third, when phytoplankton die and sink to the seafloor, they take up iron with them. Ironically, iron is often the nutrient that limits phytoplankton growth in open ocean waters. And yet here it is, raining down from the sky in places where there are already a lot of phytoplankton, giving them even more access to this precious resource. So depending on the strength of the eruption and the location of the volcano, its far-reaching effects can either boost or hinder phytoplankton growth. And that can affect how much carbon is removed from the atmosphere. Researchers don't know exactly how this plays out yet. It's super complicated and involves a lot of factors. But the first step to figuring it out is pinpointing just how much CO2 is being sunk by phytoplankton in different parts of the ocean. To do that, scientists have been dropping these cute little devices called land sea, and ice profiling, floats into the ocean. These little yellow submarines are equipped with sensors that measure temperature, salinity, oxygen levels, and crucially, the amount of carbon dioxide dissolved in the water. Every few minutes, the float takes a measurement and then dives deeper, storing that data until it reaches a depth of 750 meters, where it releases the information into the ocean's data collection network. Eventually, that data makes its way to researchers who can model how much carbon is being taken up by phytoplankton in different areas of the ocean. One team of researchers used these floats to study the impact of two nearby volcanoes, one that erupted frequently and regularly, and another that hadn't blown in over 500 years. The team found that the regularly erupting volcano led to more phytoplankton blooms, which removed more carbon dioxide from the atmosphere. But these volcanoes aren't the only ones that researchers are studying, because not all volcanoes behave the same way. Some scientists are studying Mount Ibu in Indonesia, which has had at least 28 major eruptions in the past 500 years. They're looking at the chemical makeup of the lava to understand the role that gas plays in shaping an eruption. By understanding how gas affects eruptions, scientists hope to better predict how big an eruption will be and whether it'll send a lot of sulfur dioxide into the atmosphere. Meanwhile, other researchers are investigating El Hierro, a volcano off the coast of Spain that hasn't erupted since 1793. Scientists are studying its history to determine how underwater volcanoes evolve and how they interact with marine life. That's because while El Hierro has been quiet since the late 1700s, it's overdue for an eruption. Since 1994, the island has been swelling and scientists have detected almost daily earthquakes around its southern flank. They believe an eruption is imminent and that it will happen underwater. And it's not just happening at El Hierro. Undersea eruptions are thought to have played a significant role in removing carbon dioxide from the atmosphere during periods of rapid climate change throughout Earth's history. Studying how underwater volcanoes interact with the ocean and the atmosphere could teach us how to fight future changes to our climate. Of course, volcanoes are unpredictable and trying to influence how one behaves is extremely dangerous. But scientists think that understanding volcanoes better could help us reduce the impacts of future eruptions. Knowing how volcanoes work can help governments plan ahead for the damage that they cause. And knowing how volcanoes interact with our atmosphere can help us develop ways to prevent or mitigate the effects of future volcanic eruptions. Volcanoes are also important for the health of our planet for less dramatic reasons. For example, volcanoes bring fresh minerals to the surface that help replenish soil. In places with volcanic soil, farms are able to produce more food with less fertilizer. And when volcanoes erupt, they release greenhouse gases that have been stored inside the earth for hundreds of millions of years. These gases often include methane and carbon dioxide, both powerful greenhouse gases. Releasing these gases helps to balance out the amount of greenhouse gases humans put into the atmosphere. There's a lot that we don't know about volcanoes, but as we learn more about how they work, we can better understand the risks and benefits they pose. We've been focusing on how volcanoes might help us fight climate change, but as we've seen, they can also cause terrible damage. Understanding volcanoes is about balancing risk and reward. As we learn more about volcanoes, we can better understand those risks and rewards and hopefully come up with new ways to harness the power of these magnificent beasts. Thanks for watching this SCI show video.